Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the largest pivot I've ever seen. I've sold this pivot in the past. And this is a Rixson pivot. This is their SPLO-3712. And this pivot can handle a 3,000-pound door. And this video is going to primarily serve as a review of what the item is, its dimensional properties, allow you to see it. In my career of 3+ decades, I've sold, there was one project that we sold, I don't recall, there may have been 4 or 6 of these, something like that, or 3 of them. And it took months for the material to come in. This item was ordered. This item took almost 4 months, 5 months to arrive to us. So this is for stock. We're going to keep one of these on the shelf because it's hard to plan to get a heavy door hung when you really can't tell how long it's going to take to get the pivot hardware. So this video is going to start out less typically than most videos, where I'm going to start with a review of the one piece of paper that they include with this extremely expensive piece of hardware. We're going to review this piece of paper first, and then we're going to take a closer look at the hardware itself. We're going to discuss the pieces. I will attempt to put the installation instructions, really a technical drawing, through its paces to make sure that there's really nothing missing, anything that you might need to watch out for, etc. We're going to look at as well, and probably talk a little bit about where you would end up using this. So let's switch to the screen view now. Okay, here is the item that we are looking at. We'll take a look at some photos in a moment, but let's tackle that document that comes with the hardware, and it's linked to right here. It's called a sample technical drawing, at least at this point, and it's the only known document that exists of this. The manufacturer, Assa Abloy, uses the prefix SPLO. Not only Assa Abloy, others, well, maybe it's just Assa Abloy companies use SPLO special layout, and that is the record locator. This is special layout 3712. So at some point in the history of Rixson, someone said to them, I need a pivot that can handle, I need a center hung pivot that can handle a 3,000-pound door. Well, their engineers went to work and created SPL-3712, and here it is. This paperwork does nothing to prepare you for the sheer massive piece of hardware that ends up showing up at your desk. The item, everything on this page, it's fasteners, and the box it ships in weighs 77.85 pounds. This is a pivot that weighs almost 80 pounds. It's nearly inconceivable to think that a single center hung pivot weighs well more than a case of hinges, but it does. So first of all, with something new like this, yeah, we're gonna want to review what they call instructions. So let's go through these. Let's go through these. This is anything that's going to be a hidden rattlesnake is very often in here, in the sense of you're going to want to read it to make sure that you're aware of it being there. Install bottom arm in door. Okay, it's that easy. Install top pivot door portion in door. Install top pivot frame to underside of header structure. Locate bottom spindle with plumb line from the top frame portion. Grout cement case level and plumb 1/16 below the finished floor. Attach the finished floor plate. That finished floor plate's probably 1/16 of an inch thick. Position bottom arm on spindle bearing. Lift door to align top portions. Attach bottom arm block loosely with 4 screws. Extend top pivot pin into frame portion, tighten set screw. Tighten bottom arm block screws securely, replace access panel at top pivot area. And I think a lot of what that says there, out of context of being able to see the hardware while we read through it, is difficult. So when we switch back to the screen view, if you leave this document open on a monitor as you watch the video, I'll go through this step by step. So the rest of this document is really nothing other than dimensional properties of everything else. Now, to me, what's really important to try to sort out is some stuff that the factory isn't helping us with. And what I mean by that is, what's the minimum door thickness? So, and these are just, what I'm about to discuss are items that come to mind that need to be figured out. And so minimum door thickness. Well, your arm is 4-inch wide. So that's going to help you understand what the hardware is so that you can determine what your door thickness is going to be. And that project that I referred to earlier was from 2018 where we did 4 of these. But I don't have any information in terms of what the client hung with this massive pivot. So if all of this is going to be 4-inch, that's all the information they're giving. You'll have to decide based on your door design. You'll have to incorporate this into your door design, is what I'm driving at. So we can see that that's 4-inch, so that will give us some idea in terms of what our door thickness is. The other thing that they're not telling us is, what is the undercut? So 1 3/4 is what they're showing from the top of the faceplate to the underside of the bottom arm. So it seems to me that your undercut, so it's going to be 1 3/4 from here down to here. Knowing that dimension is important because it will allow you to design your door. Now, does it have to be 1 3/4? No, not at all. It can be smaller. I would think 1 3/4 is a really heavy amount of. I'm using the term undercut. I should use clearance. Clearance is the what would be the bottom of the door to the top of the floor. So 1 3/4, whereas undercut is the bottom of the door to the bottom of the jamb. We don't know where the jamb is here, if there is even a jamb. So we've discussed how thick the door is. Well, all that we can tell you is that this is 4-inch wide. You have to incorporate this design. Number 2, we're talking about clearance. Well, we know that it's 1 3/4. The third concept, which dovetails into the second concept, is the side load. There are side load pivots and end load pivots. This is a side load pivot where once this arm is attached to the bottom of your door, you will literally have a notch in the face of the door so as to accommodate the spindle that's coming out of the bearing that will then seat into the bottom arm, which you will then secure with this arm block and the bolts, of which there are 4 of them. So just to discuss side load and end load, let's do that now. End load is very common, and this is what an end load arm looks like. That's an end load arm, where in the edge of the door is where you will have the spindle approach the pivot bottom arm. End load. Well, end load works in lots of instances, but in a case where your pivot point might be 18 inches from the end of the door, an end load would be quite impractical. Then you're going to use a side load. This is side load. This happens to be for probably an H117-3 an H28 closer. Okay, same thing really. So this is what a side load arm looks like, because that pivot point could be quite well away from the edge of the door, or you could be dealing with a wood door and it would be very impractical to route out that entire bottom of the door to get the spindle to the arm to where the arm block can secure it. So that's what end load and side load look like. So this is exclusively a side load product, which would be very typical. A pivot like this is very likely going to act as it could act as a revolving door, and in fact, I think these 4 openings from 2018 were revolving doors. Or it could be just a door that's 5 foot wide and it's 14 feet tall, and it literally weighs over 2,000 pounds. It could be something like that. And your pivot point is X away from the jamb, whatever X is. Now, so we've talked about door thickness, we've talked about clearance, we've talked about side load. Another major unknown that you have to think about before anything is done is what is the gap between the edge of the door and the jamb. So I could in AutoCAD relatively easily show you what that might look like if I were to draw, if I knew the door thickness and I knew the dimension of where the pivot, the vertical axis of pivot was from the jamb, I could derive what the gap needs to be based on the edge of the door. Is it square-edged? Is it radiused? Is it bull-nosed? So I could derive that through AutoCAD. But let me see if I have just an easy video I can get my hands on to illustrate the concept. Yeah, I do. So here's a video of a client likely asked at some point, you know.
All right, so what we have here is a client has asked me to demonstrate what the 1/4 inch radius gap looks like on a bomber 7800 series. And is a 1/4 inch necessary gap, and what its relationship is to the 1.5 inch radius. Well, I have a door drawn here, and it is...
So now imagine for our SPLO, whatever it is, 3712, yeah, you know, we've got an unknown thickness, we've got a dimension from the jamb to the vertical axis of pivoting, we've got a treatment on the edge of the door. This happens to be radiused. And what we're trying to derive is, what's this dimension?
Inch and 3/4 thick, 1.5 inch radius, and I've got a 1/4 inch margin that's there. Okay, so let's take a look and see what that looks like. So let's rotate the object. Okay, so that's what the object looks like as it rotates through.
Let's back up a little bit. So what I've done here is I have basically duplicated what's on the template. An 1.5 inch radius, a 1/4 inch margin. And now I'm rotating.
Okay, so that's what the object looks like as it rotates through.
So
let's copy. Let's put it at 35. Okay. Let's do that again. Let's rotate it.
the point here being is that through, you know, some software, we'll help you determine what that needs to be. But without knowing the door thickness, where the vertical axis of pivoting is located, and what gap you need to have, or what the door edge treatment is going to be, there is no way to know what that dimension needs to be. So we need those variables. But we can absolutely provide that. Someone can provide that. And that's what needs to be understood. So now we've talked about, well, how much margin you need. And that goes not only for the pivot style, but it goes for the opposite style as well. So all of that needs to be thought out during the design phase. Now, as a distributor, by the time I get the quote request or the PO for this material, all that's been thought out. In most instances, customers aren't coming to me and saying, I need you to detail all of this. But just so that we are clear about detailing all of this, we can. But those will be the variables that will need to be addressed directly. So what I'd like to do is take a look at the images that I have, the photographs that I have of this item. Then we'll switch back to the screen view. And then we'll look at the parts while you keep the installation instructions up on a monitor so that we can kind of do a reality check on all of this. So let's look at those photos. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, let's take a look at those photographs that we have. You know, you've got the top pivot, and you've got the floor portion, you got the door portion, and you got a whole mess of fasteners. It's really no different in terms of what's in here. And in fact, other than the fact that you're dealing with an obscenely heavy door, most definitely, this is typical hardware. All right, so you're looking at a top view. This is what the underside of the door would see. This is a cross-section type of an elevation view of the header portion of the top pivot, showing the top pin all the way projected down. That's a roll pin, and when you remove that set screw and lift all that up, you remove the set screw completely, you can then push the pin in, and then once you get the door hung, you drop that pin down into the door portion, into this bearing that's in here. You then secure it with this set screw, and then your door's hung at that point. Your installation's complete. Which is why they tell you to first install, you know, get everything attached, because that's the business end of this work. Now, this is showing the bottom floor portion and the door portion. You can start to think about how epic that is. 4 inches wide. Just showing it rotated. That will 360-degree rotation like a revolving door. The top view of that. Great view of showing the side load. Those 4 bolts come out. That arm block comes out. That's the spindle coming from this, goes all the way down here, and there'll be another photograph in a moment. That spindle goes all the way down here. That's that 1 3/4 dimension we talked about. Close-up of the arm block. That's how it comes from the factory. It's secured. The underside. These funny, weird things. What in the world are those? These fasteners. Attach those. Lugs is what they're called. Those are called lugs. This is meant to be installed into a bed of concrete. That's how the factory intends that you're going to install this. That's the underside. Showing the end of the unit. If this was an end load, that's where the arm block would reside. Let's take a look at another set of photos. Fasteners. These images are a bit out of order. Yeah, let's look at this next. Showing the bearing assembly, just an outside perspective. One of those lugs, positively massive. This dimension is the entire width of my fist. Now our top pivot assembly. Pivot pin. This is the header portion, door portion. That's just, there's so much grease packed in there that they insert that piece of bubble wrap in there to kind of keep your fingers out of it. Header portion, set screw. I think I show where I've removed it. There it is. So here it's extended. It cannot go up. When I remove that set screw, I can then drive it up, and that's how you hang the door. Showing the underside when the pin is fully retracted. So this, now we're going to look at the bottom of this, and there it is. Interesting. Very interesting. So we have to be mindful. How are you going to service this? They don't indicate that on the installation instructions. you're going to need to have an access hole through through the wall, in fact, in order to get to that set screw. Because if you don't have it, and I'm saying that because there's clearly an access hole here to lift that roll pin up and down. So you'll need an access hole here to get to the set screw to be able to remove that completely. And then you'll be able to insert a tool to push that roll pin up, to drive that pin up, should that door ever need to come down. Showing the top view down, you can see how that hole aligns. And, you know, when the manufacturer makes these instructions, I think it might be somewhat fair to say that the people at the plant don't spend their careers installing this material. They can engineer it, they can design it, they can manufacture it. But there might be nuances that occur in the field that they may not think about immediately. And there have been, there was a pivot recently, and I forget, it might have been an H117. There was just, it needed more clarification on the clearance. Actually, it was an H117, I think 587. So going through this information is crucial, because the factory may have missed a point. To you and me, eventually you're going to say to yourself, well, how in the world do I get the set screws secured? And it will arrive to you that it'll dawn on you that the only way to do that is you have to have an access hole. There's no other way to do it. The pin must be fully removed in order to get that roll pin up and down. That is showing the top view, and then the door portion. Let's see. The underside of, well, the top side of the door portion. This is what you would see if you looked in the top of the door. Lots of grease in there. Unfortunately, these scratches, that's just a result of how they packaged it, which was insufficient at best, which is unfortunate. This is a $10,000+ pivot, and they used very simple bubble wrap to ship this. An 80-pound box in a single wall cardboard box, mind you. That doesn't seem, that Rixson needs to do that better. Fasteners, well, the underside fasteners. You're going to have fasteners for the arm on the door. You're going to have fasteners for the top pivot in the header and the top of the door. And you've got an extra set of 4 here, but the question is what are those for? Well, these bolts are a greater diameter than these bolts, and the only thing I can think about where that would be for would be as if you were going to remove the lugs and try to mechanically fasten this down somehow. There's nowhere else for those bolts to go. And here are some individual photos of the bolts. I'm not sure what grade these are. They're probably grade 5 or higher, would be my guess. Those would be the... these are probably the bolts that you might use to replace the lugs with. It's not indicated on the instructions. These are the bolts, machine bolts for the bottom arm, should you need to drill and tap. These are wood screws. I would imagine if you're going into a structure that has wood, that would go through the underside of the arm into the door structure. And then our last set of images. Yeah, these I already showed. These are for the top pivot. If you've got a machine application. What's interesting is they don't give you wood screws if you, for some reason, have a wood header. So you're getting machine bolts for the top pivot. And be mindful, this is the way that this material was engineered. So leaving the reservation, so to speak, you know, the way that it was said to me is, do you really want to remove those lugs, not install this into a bed of concrete, and count on the shear strength of a common wood screw to secure a 3,000-pound door? No, the answer is no, of course you don't. These are machine screws for the finished plate that will go on top of the unit. That's what it is. And there you go. Installation instructions, that's the last image. So let's switch back to the screen view and let's go over these instructions step by step. That's what we're going to do right now. Let's go over what we've got going here with this Epic pivot. So, little camera perspective change. I mean, just in context of my arm, I mean, it's overall length is 16 inch. 4 inch? I don't know what that is. 1.5 inches. Okay. Now you can see here that what we need to do is to remove those bolts holding the arm block in, and I'm going to get a wrench and we're going to do that. Actually, I already have it. Now, in my experience, those arm blocks are fit in there really securely. Because I want to show you what the spindle looks like. Should have done that one. Let someone else grab that. AB supply. Let's continue taking these bolts out. Yeah, that arm block starts to come out pretty well. Just a massive piece of steel, just massive. That arm block alone weighs 2.22 pounds. Yeah, and generally getting the arm off the spindle is never simple and straightforward. It's fit on there fairly well. Rocking it up allows me to separate it a little bit. Now when you look at the drawing, you can see what they're showing you. That's what they're showing you. I mean, I have it turned around. I won't even try to weigh this. That's your spindle. It's 1.5 inches by 1.5 inches. Oh my gosh. I can barely rotate that by hand. It's really massive. This arm can actually go on either way, this side or this side. They've countersunk both sides. You know, they don't know. You know, does it really matter how you're going to install it? Yeah, it really would, because you might, they need to countersink it from both sides, because your side load might come from this elevation, it might come from this elevation, and you might want the shorter end towards your jam, I would imagine. Your jam will be over here. I'm actually going to leave that separated. I'm going to put the arm block in here secured loosely. And we're going to continue to take dimensions of this item so that we can have an idea of what it actually is. That did not go in freely. You don't want to force it. You do not want to cross thread anything here. So as soon as it resisted, I backed up so that I wasn't going to cross thread anything. It would not be fun to have to try to field repair a cross threaded situation on such a piece of equipment. Okay, we've got our bottom arm, the arm block put back in. Now, the floor portion. Looks like it's about 14 and 3/16 overall length. 14 and an eighth maybe. Overall height, looks like it's about 6 and an eighth. The dimension from the top of the case to the end of the spindle looks like it's about 3 and 3/8. This dimension is what I'm driving at. It's about 3 and 3/8. Height from the floor to the top of the cement case is about 3 and 7/8. I don't know if you can see that. About 3 and 7/8 right there. The length of the lugs, about 3 and an eighth. You'd be able to remove those. Now there are these larger bolts. These larger bolts came in a separate box from the factory. So I'm imagining that if you're going to drill and tap this down to some sort of steel structure, you would use these. But the truth of the matter is, you'd only need 6. And frankly, there's nowhere else to use these because they won't fit in the header portion. They won't fit in the door portion. So don't really know where they intended those to go other than here, because this is the only area that they would fit in. However, I have a theory. No, well, there's not Siri. Please ignore. Yeah, it says pack of 25. There were 20 of those bolts, so I don't know where they would go, where you would need 20 of them. This is the only area that they would fit. This is meant to be mortared in. Concrete is the only fastening material really intended for this. Now the finished plate is here. I'm not going to remove it from the packaging because it's so well taped closed, but you sure get the concept that that's going to sit right down and over that. Now let's take a look at the top pivot assembly. Just leave that there. Now I had talked about earlier driving out that, or removing that bolt. Same Allen wrench worked at both ends, and that is a 3/16 is what that is. It's a 3/16. Worked for the arm block. So I've got to completely unthread this. This will not move. That won't move. Completely unthread it. Some white lithium grease in there, I believe. That will come out. That access hole I talked about earlier, right there, would allow you to push that roll pin up, which you would need to force something in there for sure. That's going to allow us to get that pin driven up. Okay, it won't come out. That's how it's going to work. So what's another issue that I think we can detect? This is going to be up in the header in your door portion, which we'll look at in a moment. You're going to need a way to get that back down after you have, again, that access hole we talked about earlier, to get that bolt out of there. That'll have to come out. You'll need a cap in the face of the wall, or the header. You'll be able to push that up. Getting it back down might be a trick. You might need to insert a piece of stiff rod, a stiff wire in there to be able to get it up and hook it and drag it back down. The problem with that is getting that back out. I don't see how you're going to get that tool out. Well, yeah, probably what you'd, because that's not just falling out from gravity. Getting something to the face of this and getting it pulled out, actually with a little bit of movement, it seems to free up just a little bit. So you'd really have to decide how you were going to get that pulled out. Yeah, it came down, so maybe exercising it a bit will allow it to come down, but you'll have to get that pin fully down. I might be challenged to use a piece of, quite frankly, I might hook a piece of string on there before I did the installation and had that string tied to this and coming down. Is probably how I would do it. Because that string I could easily cut back. Or in fact, try to fish it through. Well, anyway, there's no cover plate for this, so you'll see anything that you leave there. When you look up into the header, this is what you're going to see. So let me put the bolt back so that we don't run the risk of losing the bolt. I'll just thread that in a little bit because it's already secure. Now some dimensions. This is the header. Looks like it's about 12 inch and 2 3/4. That thickness is probably 3/8. It's 1/2 inch. The diameter of the pin is 1 inch, and its projection looks like it's about 2 1/8. So you're going to have every bit of 1 3/4 of this pin into the door portion, which is here. That's really covered in grease. There it is. Overall length of the door portion, 12 inch. 3 inch. Thickness, I'm assuming it'll be 1/2 inch. This boss, this isn't a boss. I'm not sure what to call this. This female receiver of the top pin. It's 3 inch diameter. So 3 inch up at the top. Again, this is 4 inch. Now, how this is going to go together, obviously you're going to remove that bolt, push the pin up. The door is going to be at some angle to the header. You're going to get this vertical axis of pivoting lined up. It's going to look like this, basically, right? Your installation will look like this. Your pivot pin's going to be pushed up. You'll get those lined up, and that's tapered there to allow you to obviously guide that into the bushing down below. And then, you're going to need to, hopefully that piece of access string, you'll get it locked in place, and you'll be able to pull that down and secure it. And at that point is when you'll be able to insert through your handy access hole this Allen bolt. Okay. That's how that's going to go. You're going to get machine bolts for the header portion, black oxide machine bolts. You're going to get machine bolts. This would be for the bottom arm. Okay. There are 7 of them, more than needed. Oh, wait a minute. Two, 4, 6, 8, 10, 11. These are too large and too short. So in my estimation, we don't have enough of these machine bolts. Yeah, at all. Even close. These short ones will fit up here. No problem with that. So we'll have to make the factory aware of the fact that we are short a number of bolts. These are probably number 24 wood screws that are 4 inch long. That would fit here. 2, 4, 6, 8, 10, 11. Yeah, there's 11 of them. And then there are 7 here. So what could that... 11 is good here, if it's wood. 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. We've got enough for here. So we don't have enough for the arm in a machine application. We do have these bolts if you were going to try to bolt this down. So I think we've got to let the factory know that we're short of this 2.5 inch flathead, Allen drive, probably 3/8 would be my guess. We'll have to let them know that we're short those, which I will, and then we'll get them added to it. That's one of the good reasons about going over the project before you start. And then lastly will be the, so probably 1032 flat undercut head machine screws for the finished plate. This finish is 630. They can make this architectural plate really in any finish that you want. This is just stainless steel and a brushed finish. Okay, let's switch back to the main camera and we will wrap it up. Pardon me, we're going to switch back to the main camera and we're going to go over the instructions, looking at this material step by step. Regarding the links to ads that you might see in this video, we do apologize for any interruption to a smooth viewing experience. And hopefully the ads that are being presented to you are related to the base product. And if there is something, feel free to click on those and perhaps consider taking a look at what that other advertiser is promoting. Let's get back to the video. Okay, let's start with the instructions. First, everything I said leading up to this point about the top pivot is the exact opposite of how it actually is. This is the door portion. Okay, the installation instructions clearly call this as the door portion. I might think to myself that that could be difficult from the perspective that and I don't know, I'm not an engineer at Rixson, but when this gets installed in the top of the door, you have to somehow pull that bolt out and you've got to pull the bolt out. Although it does make sense. I'd set up to this point, you'd need an access point in the face of the header. Well, when you install this into the door, you're going to need an access point in the face of the door. That's not unusual. That's not unusual. A hole can be drilled, a cap can be installed. What my concern is getting the top pin engaged in the header. Now, I'm concerned with that because here's the top of the door. The top of the door is turned to 90 degrees. Here's the header portion. It's going to literally sit like that. Let's say that your wall is 5 inch thick, or your header. How are you going to get to that hole right here? You've got no margin. You've got an 1/8 of an inch margin, let's say, between here. Your wall occupies this much space. So I don't see how you're realistically going to get that pin pulled up. You'd want to have some means by which to get that opened. The point is that this would normally be the header. It's easier to get the door open to get to that hole. But that's assuming that your doors, this was 3 inch wide. So you'll have to really think about how you're going to get that pin pulled up. If it was me, because if I couldn't get it pulled up, it's not going to be easy. At that point, you're trying to get the door brought up to it. So we'll go over that in a moment. You're going to need to pull that pin up. So we're going to let that sit for a minute. I don't know if I've got a good idea just yet, but I wanted to address the fact that this is the header portion. It's clearly indicated in the installation instructions. I clearly ignored that entire section of the installation instructions. Nothing else changes. It's just where you put the material. Thinking about that retractable pivot pin. Ah, that's how they do it. Door to have 5x5 access panel. Again, clearly states it right there. So a 5x5 access panel is certainly going to allow you to get to that pin and pull it up or pull it down. That's how it's done. You don't need you need an access hole. It just happens to be 5x5, 5x5. That's how that's solved. Could you flip it around and do it the other way? I suppose you'd need an access panel on your header. I don't see why that would be a problem to invert all of that. In fact, I might like the pivot pin having gravity keep it in place rather than gravity fighting against it. Gravity pulling against it. Okay, so we've covered that. You know that there's some thinking that you have to do there, and a better job than me of actually looking at the entire sheet rather than just this and then this. Because I glazed at that and figured it was like every other Rixson template I've ever seen. Well, they flipped it over and they called out an access panel. Could you do that more elegantly? I suppose, but you're going to need a way to service it down the road. You're installing this not necessarily only for you, your boss, your owner, whoever's paying the bill, but for the guy 10 years down the road who has to service it. All right, so step one, you've got the installation instructions. Install bottom arm in door. Okay, well, this is the bottom arm. I've reattached the arm block. This would be removed. Well, whatever. It can be attached or not. It'll have to be removed. You're going to get the bottom arm attached. This, whatever side you put the arm block on, is the side load face. I would assume that the notch you're going to make in the door for the arm block to come on and off, a service panel, will be the same side as the top. That would be my assumption. When you have that arm attached to the door, you're going to fit that whole square prep in the arm to the spindle. Before you get there, though, step two, install top pivot door portion indoor. So all of this has to get prepped and attached to your door. So right now, I've got all of this attached. I've got the screws off the table. I've got it all attached. Okay. Step 3, install top pivot frame portion to underside of header structure. Well, that's this. Okay. You've got the dimensions. Your design will determine how you're going to attach this. Locate bottom spindle with plumb line from top frame portion. Okay. So, before you've attached this, you've determined where the vertical axis of pivoting needs to fall. You've decided from the jamb over, this is how many inches over it's going to have to be. So you've done all of that as we discussed earlier. Now, the next step, step 5, grout cement case level and plumb 1/16 below the finished floor. So you've got this positioned. It's exactly where you want. You now have to get this placed onto the floor. Where do you place it? Well, what they say to do is to use a plumb bob. How I might go about using a plumb bob is I would probably get something that would act as a dowel rod, and I would drill a hole through it very accurately, and I would drop a plumb line down through it and rest a plumb bob right where this has to sit. I've got a big giant hole already prepped in my floor. I've got some mortar mixed up. I have my bottom bearing assembly, all of the floor portion. And I've got my plumb bob ready to go. You got to get this into the floor, get it positioned, pour mortar around it, and have it exactly where it needs to go. My suggestion, and it's not my suggestion, it's Rixson's suggestion. You'll see it mentioned when you're setting floor closer bodies. They've got some straps that can go along this. You can drill them and then attach them right to the body. I might use a small washer so I get my 1/16 of margin to allow for the finish plate to sit down. on top of that so that the plate is flush with the floor. You might run your straps diagonally, however you might end up doing that. And then once you've got it positioned and you're right where you need it to be, you've got to check with your level to make sure that you're truly level. And the point of those straps is to make sure that you are level with the floor, but then your tool, your level, is going to make sure that you're perfectly level. Plumb bob should be spot on, and you should be perfectly level. That is step 5. Step 6, attach the floor plate. I might wait on that. Position bottom arm on spindle bearing. Lift door to align top portion. So the bottom arm is attached. Now you're going to get this massive structure set right on top of here. And the notch in the bottom arm is going to fit right over this. I don't know that I'd do anything with the arm block just yet. Although they're saying attach arm block assembly loosely. Makes perfect sense. Door is sitting on there. It's probably up in the opening now. Arm block assembly loosely, they say. Obviously don't permit the door to tip at all, but you can rotate it. Extend top pivot pin into frame portion, tighten set screw. So at this point, you've got to get this pin driven, pulled up, engaged in the header assembly. You've got that 5x5 notch here. And then you'll insert and tighten or secure your set screw, holding this pin completely extended. Tighten bottom arm block screw securely. Replace access panel at top pivot area. Okay, so that makes sense. Get the arm block attached. Now your door should be completely in position. At that point, you should be able to cycle and test the door. At that point, I would likely make any adjustments, hopefully none. Attach your access panel, covering the bolt access here, and then attach your floor plate. That would be it. So, assuming that you review all the instructions, you'll be saying to yourself, wait a minute, that doesn't seem right. But just really a massive piece of hardware. That one document, this one document, is all they produce on this. And I would say that there's... Could they add some additional language about some tips and tricks about how to get this completely prepped into the floor? I would say yes. But the rest of it, they really can't go very far because they don't know what the structure is. Is it steel, aluminum? Is it wood? What could it be? What's the floor type? But if you're really hanging something that is going to meet the 3,000 pound threshold of what this can handle, you are absolutely pouring this in concrete. There's no doubt about that. The purpose of center hung pivots or offset pivots or floor closers is that all of the weight of the door and all of the hardware attached to the door is carried by the earth, and that's the point of this. That's how this stuff really actually works. So to install it in any other way, I've had people take those H117-3/4, which are rated for 1,000 pounds, and install them in a residential application where they've cut a big hole in a wooden floor, and then underneath they've created a box. They've boxed all of that in, poured that with mortar, got their bottom pivot set exactly the way that we talked, leveled it off, and it all was splendid. This is the same concept, with the exception if this is inverted and just substantially larger than your average pivot. Your average pivot is 200 pounds or 500 pounds. You get into the really exotic pivots, now you're at 1,000 pounds. Well, this is ultra custom. This did take 5 months to come in, so be mindful of what a lead time could be on this. We'll have one on the shelf. We'll see what happens. But I generally find that people don't think ahead enough when it comes to the hanging devices for something truly, truly heavy, tall, wide, thick, custom fabricated, and there might be just an opinion that stuff's sitting on the shelf. There's nothing on the shelf to hang a 3,000 pound door. And in fact, in 2018, when 4 of these were made up, it took 2 months longer than Rixson initially said. And I can appreciate why when I see this. Rixson is not taking blocks of steel necessarily and prepping all that work in their facility. Much of this is likely brought in, sub-assembled, they're waiting for parts, their suppliers are waiting for parts. And then when you get it, there's clearly some shortage. So planning ahead can't be overemphasized. Let's wrap up this video on camera. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So if you have any questions on the SPLO-3712, feel free to reach out to us. We make an effort to actually stock unusual hanging devices. If it's not a pivot for something as Apex Predator as a 3,000-pound capacity center hung pivot, we certainly will attempt to stock, you know, the 200, the 500, 600, 700 rated, 1,000-pound rated pivots. Floor closers that are capable of very heavy weights as well. You do a lead line door, and that will easily be over 1,000 pounds. But we'll also stock unusual hinges like Harmon hinges and very wide throw hinges, like 12-inch wide, 5 by 12. We'll also stock detention hardware, hinges that will actually hang a 2,000-pound door, but it's not a pivot, it's actually a hinge that can be mechanically fastened or welded to the structure. And then, of course, 8x8 hinges and other larger than average typical hinges that you'd end up seeing. And the reason that we do so is, as I had mentioned earlier, I do find it fairly common that people fail to plan on the lead time that it took or that it would take to get their hands on an unusual hanging device. I probably mentioned earlier when we did these 4 in 2018, it took the factory 2 months longer than originally specified to get a ship date to the client. That was problematic. When the factory says it's 9 weeks and then it ends up becoming 17 weeks, it's an issue because that's not planned. Again, this took almost 5 months to arrive, so be sure to plan ahead. Below this video is a link to the manufacturer's page. If you click on that, you'll be able to pull up not only all of the Rixson items that we sell, but also a link to the current product catalog. And also on that page is a link to the 1920 product catalog. So if you wanted to see what Rixson was making 100 years ago, that would be the document to take a dive or a scroll through, just if for nothing else out of curiosity's sake. The folks over at Rixson are good quality folks. I've spoken to their tech support department over the years countless times, and they have always been extremely helpful. They have, or they had, I'm not sure that they still do, but a two-pronged approach. They've got someone who consults in terms of design, meaning they'll help you figure out what pivot you need. And then there's tech support folks. So it's the first person to figure out if you even need an SPLO-3712. And then there's the tech support department that will help you get it installed or answer those questions. When you're looking at that single sheet, this hardware is over $10,000 what's on my desk, and there's only one page that tells you what needs to be done. Now, in their defense, there's really nothing much past that you need to know. And through your first installation, you'll discover those other unwritten items that would be nice to know before you start. So the second one that you end up doing, if ever, you'll be much faster about it. So the instructions it's more of a template or a technical drawing, but it's really all you need. So if you have any questions on the SPLO-3712 or any other Rixson product, please feel free to reach out to us. And thank you. Okay, so it's been 4 months since all the prior video work has been done, and I was able to determine the fasteners absolutely that were in the video prior to all of this were basically incorrect. And what the manufacturer has said is that their actual quote was so during the video I realized it seemed to me that the fasteners weren't correct. I didn't really know what would go where, even though, you know, the actual application of what you're going to install might require that you buy other fasteners. But the flip side of that coin is it might just be a situation where you're going to install it exactly
the way that it was engineered to be installed. So I reached out to the manufacturer, sent them photographs of all the fasteners that I had received, and said, please explain where all of this goes. And the factory responded and did so quite promptly and completely, that they apologized for the confusion, that they were the wrong fasteners, the bolts, the screws. A new packer put those screws in your package on accident. They are originally for assembling while it's here in the plant. So apparently the screws, the fasteners I was sent, or the machine bolts, they're used to assemble the equipment prior to its shipping. Okay, I got that. That makes sense why I'm confused, because I don't know where some of it goes. And that something goes to the arm block. They said you can save or throw away those extra screws. Okay, great. I asked the manufacturer for a bill of materials of the fasteners. The factory responded that the customer service rep there spoke with the engineers. They stated you are missing screws and have some that are wrong. I'm having the engineers and quality control pack me the correct screw packages for you, and then they would ship them to me, which they did. And I received a box of fasteners, actually. Also, I asked them for a bill of materials of what goes where in terms of the fasteners, which they provided me. Now, I have the hardware taken out again. Let's switch to the screen view, and then let's solve the mystery of what goes where. So let's do that right now. Okay, so what we have here is, this is a photograph of everything that they shipped me. I know these are the screws for the cover plate. So not too much to see there, right? We're not worried about that too much. We've got these 3712-T6, 3712-B14, 16 and 11. We've got two sets of wood screws here. 16 of these and 11 of these. So something clearly here requires those combinations of screws. Here's the bill of material that I had asked for. There's the decorative cover plate, which is not shown here. 3712-T6s, these. Mount of top pivot door and frame portions for metal. Makes perfect sense. So the top header, the top pivot in both the header and the door portions would use these 3712-T6 screws. If it's a wood application, you're going to use these, the 013-018-48-603. Then, of course, you have the bottom arm to the door, machine applications and wood applications. That's simply what it is. Yeah. And by the time you're seeing this video, this will all be uploaded to the profile of the item. Now, let's switch back to the screen view and let's take a look at these actual fasteners. All right, so we have the 1070630s. That's for the finished plate. Those we know we had correct. Then we have the B14s. Those are going to be for the bottom arm. We've got the wood screws for the top pivot and the machine screws for the top pivot. Let's pull out the top pivot and take a look at that. Yeah, here it is. Yeah. That's the bottom arm. Ah. Okay. 2, 4, 6, 7, 8. I believe that's the header portion. Well, I don't remember what it was, but it'll be in the instructions or the manual. That's 8, 10, 12, 14, 16. That explains those 16 screws very, very easily.
Okay. I'm going to guess that these are 3/8 by about 1 7/16. Allen drive. Yeah. We can do better than that. We'll do better than that right here in a moment. Flathead screws. I'm going to say that these are 5/16 by 3 inch. I would like to do better than that. Let's do that. I have my tap set here, and I want to know what thread type that is. There's no reason to leave guesswork on this. All right, so I have a 5/16 tap here. No chance. I was right. That's a 5/16. 5/16 18 is what that is. It looked to me like it was far too small, but that goes in there, 5/16. So we know that that's the machine size for the top arm. Now the bottom arm, that's a longer bolt. Let's measure that, and we'll confirm that it's also... The reason I guessed 5/16 is because those are, I think that's what would be called a number 18 wood screw. And it's too small for a number 24, and I know 24 is a 3/8. Let's try that same 5/16 in this longer bolt. It's a little bit tight. Definitely 5/16. It's, well, shoot. We got to go with 5/16. 5/16 is going to be the answer on that. Yeah, it's 5/16. 5/16 goes in there. Okay, so it's 5/16 on those machine threads.
AB Supply, this is Terry.
Okay. And the last bolt would be probably a number 18, and this would be for the bottom arm, which I'll show you in a moment. Looks like about 4 inches the length on those bolts, which would be for the incredibly heavy bottom arm. I believe 11 was the count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There you go. Now the mystery solved on what fasteners are needed and where they all go. We know that we have the correct fasteners, and we've brought the amount of guesswork to 0. So if you have any questions on this epic SPLO-3712 Rixson pivot, and we just quoted 4 of these about 3 weeks ago, and the customer just couldn't wrap their head around how expensive they are. It's hard to explain to someone, well, when you're hanging a 3,000-pound door, the hardware is going to be pretty robust and carry a cost, which it is what it is. Thank you very much. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.